Hello learners, this is Mr. Beckwith, and you are watching another episode of Flashback Fridays. So in this episode of Flashback Fridays, we are going to look at one of, for me, is the most fun things that we look at all year, which is the life cycle of a star. The birth of a star, what happens to it over the course of its life, and then the eventual death of the star. Really cool stuff, really interesting stuff, because a lot of our chemistry actually happens in the hearts of stars, as we're going to look at today. So we're going to look at Hertzsprung-Russell, or HR for short. We're going to look at some HR diagrams and just refresh ourselves on how to read those, and then we're also going to talk about the birth, life, and death of stars. So let's take a look. All stars are born from nebula. A nebula is a giant cloud of gas and dust floating out in space. When the nebula becomes large enough, gravity will take over and it will start to compress in upon itself. When that happens, nuclear fusion will occur once there's enough mass. Once fusion occurs, the star is born. The star will burn all of the fuel that it is born with, the gas and dust from the nebula, over the course of its life. Deep inside the core of the star, fusion is forming heavier and heavier elements, like iron, oxygen, nitrogen, carbon. Over time, as the fuel is burned up, the star will expand, cool, and change color. Over time, once all of the hydrogen fuel has been exhausted in this red giant, it will explode, sometimes. What happens truly depends upon the mass of the star, as we will see in this next graphic. Some paths lead the star to become black holes. Other paths lead the star to become a white dwarf or a neutron star. So here we have a graphic looking at the life cycle of our star, the Sun. We can see where we are now. We're an average-sized main sequence star. Again, started out as a nebula, and then as the nebula gained enough mass, it collapsed in on itself, causing nuclear fusion, and that's where we are right now. Eventually, our star will expand, become a red giant. When that happens, most scientists believe that the terrestrial planets, Mercury, Venus, Earth, and Mars, they'll actually be swallowed up by the star at that point. It will continue to expand, and then eventually we will get what is known as a planetary nebula. So you have that tiny star in the center, and then the outer part of it become a new nebula. And eventually, over time, solar winds will blow that material off out into space, and you're left with a white dwarf. But this isn't always the case. So as we can see in this graphic, sometimes stars take a different route depending upon their mass. So you can see the path we just looked at with our own star, the Sun, but if the star is more massive, then there's the potential for a supernova. If a supernova occurs, you can either get a black hole as the mass implodes upon itself, or a neutron star. Hertzsprung-Russell, or HR diagrams, are a way for us to categorize stars based upon their temperature and their luminosity. Luminosity is a measure of how bright they are. So on the diagram, the x-axis is representative of the surface temperature. And you can see there is a temperature scale as well as a solar classification with the O, B, A, F, G, K, and M. These are classes of stars based upon their color, and the color is directly related to the temperature. The y-axis measures luminosity, and it's measured in scientific notation. You notice the luminosity of 1 is roughly at the middle of the scale. And if you look to the right, you will see our sun has a luminosity of 1, and that is because our sun is the baseline measurement for luminosity or brightness. Everything above that is a measurement of the brightness compared to the brightness of our sun. And again, if we go down the scale, everything that's below it is less bright or dimmer than our sun. You'll notice too that they use powers of 10 to represent the luminosity. Sometimes you'll see this represented in scientific notation directly. So it'll have a number times 10 to the whatever power is needed. So stars can move into different areas of the HR diagram over the course of their lives, as we saw earlier with our own sun. Our own sun will eventually become a red giant and a white dwarf. So it will move from the main sequence up into the giant section, and then eventually when it burns out the rest of its hydrogen fuel, it will move down into the white dwarf area. And all stars, as they go through the course of their life, will move to different portions on the diagram depending on their surface temperature and their luminosity. So I hope that review was helpful for you guys. It really is crazy to think about that all of the heavier elements, iron and oxygen and nitrogen and all of those things that make up us as humans and other living things, that they were all created in the hearts of stars, that we are literally made from stardust, which is a pretty cool thing to think about. So hopefully this review was helpful for you guys. Another thing, when you're looking at your HR diagrams, remember that scientific notation, the way that those numbers are written. And you guys have had a fair amount of exposure to that, so that should be something that you guys can handle. Hope this was helpful. Have a great day.